Yo, what's up guys? So for the next few videos, we'll be talking about trigonometry. So, if you like this content, consider subscribing, but let's get on with the video. So, the first thing I'm going to cover is something called a unit circle. So, obviously we know circle. Okay, so we know this, it's a circle, right? But what does it mean by unit? Well, you guys might be aware, like for example, like a unit rate, it's 1 in the numerator. So a unit circle, if I can draw a good graph here, has a radius of 1. So if I can just draw this, 1, 1, negative 1, negative 1. And this means that the radius is 1, right? But what's so special about a unit circle, and how does this relate to sine, cosine, tangent, all trigonometry stuff? Circles are very important in deciding angles. So if we were to have a point right here, so if I were to draw, we were to have a line here, right? And this is point, I don't know, A, B, right? Then, and so we know that this is 1, right? Because the radius is 1. So, using this point, let's construct a right triangle, okay? And this is going to be our theta right here, okay? That was kind of bad. Just pretend it's a theta, okay? Just it's a placeholder for an angle, okay? So, this is our angle. Well, how can we find the, let's start with, how can we find the cosine of this angle? Well, we know that cosine of theta, how about instead of x, I'll write theta, of theta, is equal to adjacent divided by hypotenuse. So for you guys who don't know how to find, what cosine is equal to or sine or tangent is equal to, just remember SOHCAHTOA. And so SOHCAHTOA gives the first letter of basically all the stuff you have to do. Here, let me finish this. SOHCAHTOA, okay? So, the first letter, S, this is for sine, and that means that in this it shows that sine is opposite divided by hypotenuse, okay? And I'll actually write that down over here. Sine of an angle is opposite over hypotenuse. And we see that cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But we're not going to cover tangent in this video. So, how can we find the cosine of this angle right here? Well, we know the hypotenuse is 1, right? And what do we know about the adjacent? Well, if this point is AB, then we know that this length is A long, okay? So the cosine of this angle, sorry, I meant to do a parentheses here, is equal to A divided by hypotenuse, which is 1. Or, in other words, the cosine of this angle is equal to A, or the x-coordinate, okay? And sine is equal to opposite, which is, well, looking at this coordinate, it's B. And what's our hypotenuse? It is 1, right? So it's B divided by 1, or just B. So this angle, the coordinates being AB, it is also, we can rewrite this as the cosine of theta, or of our angle, and sine of our angle. So this is why unit circles are so important, because we can see the relationship between cosine and sine. Now, let's talk about something called radians, okay? Some of you may be aware of this, but radians is just another way to measure angles. So, how many angles are in a circle? Well, we know that there's 360 degrees in a circle, right? And so, halfway, if you were to find halfway from a circle, that's 180. A quarter of the circle is 90 degrees, right? And so we can base our angles off of a circle, right? Given that a circle has 360 degrees. A radian is slightly different. A radian is an angle in a circle, about there, and we can do theta, whatever, of our angle. And a radian is the angle of the circle where the radius is equal to the arc that the angle contains. So this is also equal to the radius, okay? And so using some simple algebra, we can figure out how many radians are in a circle. Well, we know that 2 pi r, right, is the circumference of the circle, and we know that 1 radian is equal to r, or at least the arc length is equal to r, or the radius. So we can just divide it by r, and we get 2 pi. So that means that the number of angles in a circle is 2 pi. And so that also means that half of a circle contains pi radians. So we know that 180 degrees is equal to pi radians. Okay, so how can we convert between these radians? You can convert through these radians by setting up a ratio. Okay, so if we're trying to say, let's just say we have 30 degrees, and I'm just gonna abbreviate degrees as deg, okay, and we want to figure out how many radians that is. So if we use a method where degrees, or our labels, act as a variable, then we can write this as 30 degrees times pi radians, I'm just going to shorten it to rad, divided by 180 degrees, okay? And so what we want is we want to turn the label degrees into radians, and how we can do that is by canceling out the labels, or the degrees labels, so that our answer is going to be in radians. And now we just simplify this. So divide by 0, we can divide by 3, so we get 1, and we get 6 here. So we're left with pi over 6. Okay, so 30 degrees is equal to pi 6 radians. Now, what if we want to go from radians to degrees? Well, it's very similar. So if we were to have, how about pi divided by 4 radians? Remember, radians is in the numerator. We can multiply this by the ratio, which is, if we're now that we're going from radians to degrees, we're going to flip the ratio. So it's going to, instead of it being radians divided by degrees, it's going to be degrees divided by radians. Okay, and sorry, I got to write pi. Now, how can we do this right here? Well, we can cross out the label radians, and we can cancel out the pi, so we get 1. So we're left with, let me move down here, 180 divided by 4, which is equal to, what, 45 degrees. So that is a simple way how you can convert between radians and degrees. And this is very important to know, because as we move on through trigonometry, we are going to start measuring things in radians. Hey guys, so thanks for watching. So today we covered what the unit circle is and what are radians. Next video we'll talk about quadrants and what is the Pythagorean identity. So yeah, see you in the next video. Peace.